In solving this problem, we let the cube root of 3 root 21 plus 8 be equal to the square root of a plus b. And also the cube root of 3 root 21 minus 8 equals root a minus b. Now we can raise both sides of this equation to the power of 3. So with that we have the cube root of 3 root 21 plus 8 raised to the power of 3 equals the root of a plus b raised to the power of 3. Now we do the same for this as well. And so we have this. Now this gives 3 root 21 plus 8 equals to this plus b raised to the power of 3. The same thing goes for this side. Next, I'm going to call this equation 1 and I'm going to call this equation 2. But I'm going to multiply both. So I'm multiplying equation 1 by equation 2. So we are taking 3 root 21 plus 8. We're multiplying that by 3 root 21 minus 8. So we have a product. And we also do the same for root a plus b raised to the power of 3 and root a minus b raised to the power of 3. And then we have another product on the right hand side. So what is left for us now is to expand this. And we've learned that we can use the difference of two square approach for this. If you don't know how this is done, you can check my previous videos. So this simplifies as 3 root 21 raised to the power of 2 minus 8 raised to the power of 2. And we can compress all of this, take a square bracket, and we have a root a plus b times root a minus b raised to the power of 3. And this equals to 189 minus 64. And this again, using the difference of 2 squared, we're going to have a square root of a all squared minus b squared all raised to the power of 3. So this goes to 125 equals, when you do this, you have a minus b squared raised to the power of 3. Taking the cube root of both sides, we are left with 5 on this side, and this equals a minus b raised to the power of 2. What we are doing next is to subtract one equation from the other. In this case, I'm going to do equation 1 minus equation 2. So I'm going to place what I have on the left hand side on this side and what I have on the right hand side on this side. Now the difference of this goes to 16. When you subtract this from this, you have 0. And then when you take double negatives, you have positives, so you have 16. And next, we have to find the solution to this. We use this identity for that. But you know, in the case of has, we don't have a plus b. We have the root of a plus b and the root of a minus b. So let's fix the first one. So all we have to do is just to replace this with root a plus b raised to the power of 3. So we take the a cube, we replace it with root a raised to the power of 3 plus, we do the same here as well, 3 root a all squared b plus 3 root a, then we have a b squared plus b raised to the power of 3. And so now this goes to a root a. The reason for that is if you have root a raised to the power of 3, it means that you have root a in 3 places. So root a multiplied by root a gives a, and then we have root a. I hope that is clear from that point of view. So moving forward, plus root a squared is a, then we have b plus 3b squared root a plus b raised to the power of 3. So that is what is going to be the expansion for this. So I'll just put that down right away. A root a plus 3ab plus 3b squared root a plus b raised to the power of 3. Do the same for root a minus b all raised to the power of 3. And then we have a root a minus 3ab plus 3b squared root a minus b cubed. So bring all of that here, right? But this time around we are subtracting, so minus all of that. So by opening the parentheses, we can see that this negative has, multiply everything you have inside that, and we have negative root a and this, so we can typically cancel this out. It goes to 0, and this as well goes to 0. So we have 16 equals 6ab plus 2b raised to the power of 3. And we can also divide through by 2, so that we have 8 equals 3ab plus b raised to the power of 3. We are going to call this equation beta. So it's obvious now that we have to tag alpha and beta together, which is definitely what I have done here. Now we know from this alpha that the equation can be rewritten as a equals b squared plus 5. Now we can substitute a into the beta equation. So that gives 3. Now instead of writing a, we replace that with b squared plus 5 times b plus b raised to the power of 3 equals 8. So when you multiply that, don't forget that there's a b here. So this multiplies as 3b raised to the power of 3 plus 15b plus b cubed, which is equal to 8. So everything goes to 4b raised to the power of 3 plus 15b minus 8 equals to 0. So the next thing for us is to find the solution to this. In solving this equation, obviously we're going to be having 3 solutions. You can use any of the available methods. You can use the factoring method, which some people refer to as the try and error. You can use the graphical method. You can use the Cardano method. You can use the numerical method. You can use the Vieta substitution, etc. But we can see that out of these 3 solutions, only one solution is real, which is b equals half. The other 2 solutions, which I'm going to call b2 and b3, are complex numbers. So we are not regarding the complex part of that. So now we have b equals 1 over 2. So we can use that to find a. A, knowing that b is 1/2 squared plus 5. This equals 1 over 4 plus 5. A equals 21 over 4. If you would recall at the beginning of the solution, we said we should let this be equal to the root of a plus b, and we should let this to be equal to the root of a minus b. So there's a minus in between them. So I just put this way, and I put this way. So we want to show if this is equal to 1, and we already know that b is 1/2 and a is 21 over 4. So we just take that as 21 over 4 for a, plus b is 1/2 minus 21 over 4 the root minus 1/2. So when you open the parentheses, we have the root of 21 over 4 plus 1/2 minus the root of 21 over 4 plus half. So this and this goes to 0, and half plus half equals 1. Before substituting, you can just say root a plus b minus root a plus b. By opening this parenthesis, this cancels this, so you have b plus b, which is 2b, and b is half, so we have 2 times half. That's equal to 1. If you have a better way of solving this problem, let me know in the comment section. Please like this video and subscribe to this channel. Thank you.